A concrete surface does it all. It's durable, versatile, low maintenance, and indicates quality construction at first glance. Advances in concrete technology are also opening up a brand new panorama of design effects and capabilities. From colored pattern-stamped concrete to homes built from insulating concrete forms, aesthetics alone provide reason enough to choose concrete. But when discussing exterior application in particular, perhaps a more practical reason for promoting the use of concrete is its longer life expectancy and minimal maintenance versus asphalt. With today's technology, the relative costs of concrete and asphalt are nearly the same. If repairs are necessary, they're typically smaller in scope with concrete than asphalt. A University of Minnesota study shows that maintenance costs when choosing concrete over asphalt were reduced 75%. Technological advances continue to reduce the cost of concrete paving while improving performance. In contrast, new asphalt technology improvements are disproportionate to the increased cost. As an industry, concrete takes a proactive approach to energy conservation and emission control. The emphasis on positive environmental impact is extending to every component of production. The industry's emphasis on recycling is another factor that makes concrete an environmentally friendly building material. In fact, the practice of recycling extends to most phases of concrete production, including the fuel to heat cement production, the materials used to make cement, ingredients in the concrete, and new uses for the byproducts of cement production. Even after it's been placed, concrete continues to provide relief to the environment. Concrete stays significantly cooler in the sun than asphalt, therefore it's not contributing to the heat island effect in the atmosphere. And finally, because of concrete's brighter color and reflective nature, it reduces the need for exterior lighting, which saves on energy. The ability of concrete pavement to maintain its surface texture results in safer, more pleasant conditions for driving and recreation. Concrete pavement provides better skid resistance in blacktop, and the absence of rutting or potholes means there are fewer obstacles to cause damage or loss of control. There's also no risk of water accumulating in ruts, and concrete is less slippery when wet. The hard surface also makes it easier for rolling wheels, which can increase fuel efficiency. Not only do heavy trucks get up to 20% better gas mileage on concrete, the absence of spring load restrictions can reduce the number of truck trips. But at the very core of all the benefits and successes of a concrete project is the contractor, who is responsible for proper placement to ensure its lasting effects. The quality of the completed concrete project always begins with good planning. Spending time at this stage is a wise decision that can help to eliminate possible problems later on. There are 6 basic steps involved in placing quality flatwork. They include subgrade preparation, slab design, mix design, placing and finishing, curing and sealing, and aftercare. During this video, we'll walk through each step and demonstrate good, safe practice on a real-life project as workers place a new concrete driveway. As a contractor, you should be seeing to it that the subgrade has been adequately prepared for concrete placement. Any pockets of soft soil that cannot be uniformly compacted must be removed and replaced with suitable material. Make sure the subgrade slopes away from structures enough to ensure good drainage, and never place concrete on frozen or muddy ground. Step number 2 is making sure you have the proper slab design for the bulk of its use. The slab should be a minimum thickness of 4 inches, thicker if heavy trucks will be driving on it. Control joints should be placed at a maximum of 10 feet apart and should be at least a depth of 1 inch made by sawing or tooling. Use a centerline control joint when driveways are more than 10 feet wide. In addition, isolation joints are required at existing slabs, structures, and objects. Isolation joints should run the full depth of the slab. Step number 3 is making sure you're using the proper ready-mix design. In most cases, air has been purposely added or entrained in concrete to make the finished, hardened concrete more durable and fracture-resistant. For flat work like driveways, steps, and sidewalks, hardened concrete should be 6% air by volume, plus or minus 1%. Water-cement ratio also has an important influence on the quality of concrete produced. A lower water-cement ratio may make the mix more difficult to place. Too much water will result in settling and segregation of the sandstone components, leaving more sand in the top layers because the stone will settle at the bottom. A mix with too much water will also likely experience more shrinkage as the excess water leaves, resulting in internal cracks and visible fractures, particularly around inside corners, which again will reduce the final strength. Slump tests should be conducted to determine the consistency of fresh concrete and to check the uniformity of concrete from batch to batch. Unacceptable slump measurements usually indicate improper mix proportions, especially the water content. Typical upper Midwest flat work should be a minimum of 4,500 psi air-entrained concrete with a water-cement ratio of 0.45 and a slump of 4 inches plus or minus 1 inch. It is not recommended to exceed this water content ratio. Exceeding this amount will diminish the quality of the mix. Step number 4 is proper placing and finishing, which begins with the smooth delivery of concrete to the job site. This step is critical because any delays in the delivery of the concrete or during the placement operation may cause problems that are time-consuming and costly to resolve. All concrete should be placed within 90 minutes from the time it was loaded into the mixer truck. It should be placed as near to final position as possible. The concrete should not be dumped in a central location and spread to the location required in the structure. Concrete that will be visible, such as slabs like driveways, highways, or patios, often needs finishing. The only finishing operations required are screeding or strike-off, bull floating prior to the appearance of any bleed water, a waiting period for the water sheen to disappear, edging and jointing, and a broom texture. Screeding or strike-off is the process of cutting off excess concrete to bring the top surface of the slab to proper grade. A straight edge is moved across the concrete with a sawing motion and advanced forward a short distance with each movement. Bull floating eliminates high and low spots and embeds large aggregate particles immediately after strike-off. This looks like a long-handled straight edge pulled across the concrete. Jointing is required to eliminate unsightly random cracks. Contraction joints are made with a hand groover or by inserting strips of plastic, wood, metal, or preformed joint material into the unhardened concrete. Saw-cut joints can be made after the concrete is sufficiently hard or strong enough to prevent raveling. Brooming before the concrete has thoroughly hardened creates a slip-resistant surface. However, it should be sufficiently hard to retain the scoring impression. A broom finish for exterior concrete is ideal and helps ensure the contractor is finishing the slab properly and not overworking it. Absolutely no finishing operation should be performed when there is excess moisture or bleed water on the surface. Curing and sealing is step number 5 of a quality project. Curing ensures that the cementitious material in the slab has enough moisture and the proper temperature to react and bring your concrete to full strength. Done properly, it guarantees resistance to freezing, thawing, and de-icing salts. There are several methods of curing. The most common is the application of a compound sprayed onto the surface of the concrete immediately after finishing that prevents the concrete from drying prematurely. From about mid-April through mid-September, a sprayed-on curing compound is the preferred method. Regardless of how the concrete is cured, air dry for 30 days and follow with a concrete sealer. Sealing is a process where a protective coating or penetrating water-repellent material is applied to keep moisture and contaminants out of the concrete. Use caution and wise cold weather practices if placing exterior concrete during later months. The final step in placing quality exterior concrete is proper aftercare. Most people are very careful about how they clean and take care of the inside of their home, yet what about the concrete walks, patios, driveways, porches, and steps? While concrete is the most durable product available for your home, proper care is a requirement for long-lasting beauty and wear. Recommendations for you or your customer on how to properly care for your concrete once it's placed include: avoid driving on the new concrete for at least 7 days. Don't allow drain water to undermine the slab and cause settlement cracks. Don't allow snow and ice to accumulate on the slab during the first year. Don't use de-icing chemicals for snow and ice removal, especially for the first winter. Use sand for traction instead. Never use de-icers containing ingredients such as ammonium sulfate or ammonium nitrate. They attack and destroy concrete by chemical reaction. Be sure to sweep areas where de-icing salts drop from vehicles. If wear shows in high traffic areas, as sometimes happens after 5 or more years, clean the surface and reseal for further protection. Your local ready-mix concrete producer is an important part of your concrete project team. In addition to providing a quality product, the producer has the expertise to ensure the proper mix design and placement for your project. Please visit our website at www.wrmca.com, or you can call us at 800-242-6298 or email info@wrmca.com.